Here's an overview of the key for the midterm. Right, this first one here is a resultant problem, okay? So it is important that this is handled as a resultant, not an equilibrium problem. So in a resultant, what we want to do is sum forces in the x direction, right there. So I'm just summing up cosine 72, 800. That's positive. It's to the right, minus 1400, getting a negative 1153. And sum of Fy is just negative sine 72 times 800. And then to find the resultant force, I take the square root of sum of the squares and get 1381 newtons. To find the angle, I do an arctangent of sum of Fy over sum of Fx and get 33.4. Now that's down and to the left because the x component of the force is to the left and the y component is negative, meaning down. Okay, then I can sum moments about A. I'll get sine 72 times 800. That'll get me the y component of that force. And then I'll multiply that by the 0.6 meters. That's clockwise, so it's negative. And then the 1400 times the 0.9 meters is counterclockwise, so that's positive. And then minus the couple. The couple does not get a moment arm. It's just a couple. The way I think about that is the meters is already in there, so I don't need a moment arm. Sum those up, I get 593. That's positive. I didn't show that direction, but it's coming around like that. So that's the first one, that's finding a resultant. Okay, the second one is an equilibrium problem. I just want to find the area of that triangular load. So it's 1/2 base and height. So that's 12,600. Now to get to the centroid of that triangle, what I do is I take 3. I have to do that because I'm coming from A. That's where I'm going to take moments about. And then I want to add that to 2/3 of 6, which will be 4 feet. 2/3 because I'm coming from the vertex. So 3 and 4 get me 7. All right, so that's at 7 feet. So that's the dimension to the where that distributed load is centered at the centroid of the triangle. So when I do equilibrium here, sum of Fx is Rax, it's just 0. Sum of Fy, I got Ray up. And then I've got the 12,600 down. So Ray is 12,600. Then I sum moments about A, MRA. Counterclockwise as I have it is positive. And then I've got the 12,600 times the 7 coming around clockwise for negative. So the MRA, I don't know if I said that right or not, but it's counterclockwise, so it's positive. So as I have it drawn there, it's counterclockwise. All right. And then the 12,600 times the 7 is clockwise. So I can solve for MRA. That's 88,200. Okay. All right, the next one here, what I want to do is I want to get this broken up into x and y components. So I need to do that for that angled arm. What I've got a pin joint at A that has 2 reactions, Rex and Ray, and I've got a ramp at D. The force, the reaction there is normal to the ramp, so that makes a 70-degree angle because the ramp is 20, so 90 minus 20 gets me the 70 degrees right there. Okay, now the strategy for this is going to take moments about A. So to do that, I do have a force up here, and that's a y force and an x moment arm. But what I need is a set of x and y dimensions that'll get me moment arms for the unknown reaction at D. So to do that, I take the 36-degree angle and multiply it by 0.5, and that'll get me the x and y components of the line from C to D. And I do that right there. And I've shown the lengths in their proper locations there. All right, so now if I do the addition to get ready to do this, I'll add 0.294 and 0.18, and I'll get 0.474. And I'll add 0.405 and 0.25, and I'll get 0.655. And that 0.655 actually goes from there to there. Okay. So now I'm set up to take the moment about A. So cosine 70 RD is the x component. The moment arm then is the y moment arm, 0.474. That's going counterclockwise, so that's positive. Then I've got sine 70 RD times 0.655. That's going to come around clockwise, so that's a negative. And then I've got the 300 times the 0.25 up there. It's counterclockwise, so it's positive. So I can solve for RD, it's 165. Once I have that, I can go sum of fx is 0, so cosine 70 times the 165 that I just found there, minus REX. Solve for REX is 56.7, and then I go sum of Fy. So I've got sine 70 times the 165 at D, minus 300, and then plus REY. Solve for REY, it's 145. Okay. All right, the next one there, I want to find this angle between of AB with the horizontal there. I've got 3 for the vertical, 2 for the horizontal. Do the tangent there, I get 56.31 when I do an arctangent, inverse tangent, I guess I should say. Then I sum moments about F. I've got 6,000 times 4 and 2 makes 6. It's positive. Then I've got 4, 2, and 2 makes 8 times RA. Solve for RA, it's 4,500. Okay, once I've got that, I can get this free body diagram here. What I'm doing is I'm cutting out joint A and analyzing it. 4,500 up. When I go sum of Fy minus sine of the angle times FAB down. FAB then is 5408. I get a positive answer, meaning it does act down and to the left, which means it pushes on A, so it's compression. Then I go sum of Fx, FAC to the right, minus cosine 56.31 times the 5408. So FAC to the right there is 3,000 tension. Once I've got that, I can go up to joint B. Got 6,000 down on that joint and the 5408 pushing up. I've got BC, I'm assuming in compression, pushing up. BD goes to the left there. All I need to do though to get BC is go sum of Fy. 0, 6,000 down, sine of 56.31 times 5408 up, plus FBC, solve for FBC, it's 1,500 compression. All right, the last one here, I needed to find a couple angles, so I do the tangents there. This angle is 53.13. This other one here is 33.69, right up there. This is also 53.13. Okay, I find the reactions, take a moment about B. I get 120 times 15 minus 6 times RG. RG is 300. Sum of Fy then will get me RBY. It's 180 down. All right, I want to find DG, so I make a vertical cut through DG. I cut through DF and EG also, so I get this free body diagram. All I have to do there to get DG is go sum of Fy, set it equal to 0. 180 down, as I have it drawn, minus sine of the angle times FDG. FDG comes out to be negative, which means it's not going down right as I drew it. It's going up left, so it's pushing, it's in compression. So there's DG. Now to get, I was looking for JN. I want to identify that MN and JM are zeros. So N is an unloaded T. So when I solve there, I get MN is 0. When I get the joint MN then JM is 0 also, because it's an unloaded T at M after I've eliminated MN from that joint. So those are both zeros. I can make the cut through that panel there. I'm cutting through JL, JN, and KP. Now there's different ways to do this. The way I did it here was I used the right-hand side with that 120 going down. Okay, I've got JL, JN, and KP as unknowns. If I take moments about P, I'll get the 120 times 3, clockwise is negative, and then I've got cosine 33.69 times JL times 6. Okay, 2, 2, and 2 makes 6 there. And that gets me the counter moment there for JL. I can solve for JL. It's 72.11. Once I've got that, I can just go sum of Fy and set it equal to 0 for that joint. I'll get the minus 120 plus sine 53.13 times FJN, which is the one I don't know, minus sine 33.69 times the 72.11 that I just found. Solve for JN, and it's 200. Okay, so there's our run through the test.